Hi everyone, it's Miss Raz again with another video. This is for 3.2, the textbook's problems out of your function and data book. I'm going to go through a couple even problems to hopefully help you out with the lesson this week. So I'm on page 85, going to do number 4, 8, and 10. Starting with number 4, I didn't write the question down here, but it basically asks you, what is the axis of symmetry of this quadratic? Symmetry. And for these problems, there's some important notes that you need. You can either find them from the video or in the front of your lesson in Core Focus on Functions and Data for 3.2. So these are the notes that I'm going to be using to solve these. First one is the general form of a quadratic. So all of our questions here are in this general form here that looks kind of like this. And the other formula I need is axis of symmetry when you're converting from general form. So here we have a quadratic in general form, follows this form here, and we want to find the axis of symmetry. So to do this, we need to label our B and our A here. So our A is the one against the x squared, so here there's an implied 1. So our A is going to be 1, and the B is right next to the x, so that would be a -4. Then plugging these into our equation here, we just have x equals -4 over 2 times 1. And of course we have to simplify this. So a -4 is just going to give us a +4. 2 times 1 is 2. And this is the fraction 4 over 2 is the same as 4 divided by 2, so that's just 2. And we get that our axis of symmetry is just x equals 2. And if you imagined this on a parabola, you could flip it perfectly over the line x equals 2. Okay, moving on to 8, same question. What is our axis of symmetry? We're going to do the same thing. We got to label our A and our B. So A is pretty straightforward. It's just the number that's next to the x squared here. So our A is 2. But B is whatever's next to the x, but we don't have an x here. So whenever you don't have an x, just pretend you can add a 0x, because 0 times x is just 0. It's the same thing as adding 0. So in this case, if we do this, we can see that our B just equals 0. Now we can plug this into our axis of symmetry formula. We get -B over 2 times 2. So -0 is just 0, and actually 0 divided by anything is also 0. So our axis of symmetry is just x equals 0. And you're going to find actually whenever you don't have an x term, or whenever you have to plug in a 0 here, your axis of symmetry is just always going to be centered 0. Alright, so that is the answer to number 8. Moving on to number 10, this one is a little more tricky. They're going to ask us for the vertex, and also if there is a min or max. So let's start off with the first question. They want to know, what is the vertex? And the first step in finding the vertex when you're in general form like this is you got to find the axis of symmetry. So let's do that first. So same thing, we're going to label our A and our B. Our A smashed up against the x squared is -2. And our b next to the x is 8. So plugging it into axis of symmetry, we have x equals negative 8 over 2 times negative 2. And that's going to simplify to negative 8 over negative 4. And again, we're going to get 2. X equals 2 is our axis of symmetry. But that's not what the question's asking us. They want to know what is the vertex. So we have the x-coordinate of our vertex as 2, but now we still need the y-coordinate. So to find that, we can just plug 2 back in to our equation as x and solve for y. So b of 2 equals negative 2 squared plus 8 times 2 minus 7. So I just plugged in this 2 to all these x's here. So this equals negative 2 times 4, because remember we have to do our exponents first. 2 times 2 is 4. 8 times 2 is 16. I've dropped down the negative 7. This is negative 8 plus 16 minus 7. And if you calculate all that out, it'll give you 1. So b of 2 is 1. In other words, y is 1. Or b of 2, it's the same thing. So we can put that up here, and this is our vertex, which basically means either the very bottom or the very top of our parabola is going to be at this point. So that leads us to our next question. Is this point the very top or the very bottom? Or rather, is this point the minimum or the maximum of our parabola? So if you guys will remember back from 3.1, our A actually gives us this information, and it's the same here, either in vertex form or in general form. If your A is negative, your parabola is going to open down, or it's going to make a frowny face. If it's positive, it's going to open up. I'm going to do this because it's negative. So if it is negative, has a frowny face, and you can see it has a maximum. And these are the answers to the 2 questions that number 10 is asking. And that is all you got to do. All right, good luck, you guys. And remember to come to office hours if you have any more questions. Bye-bye.